Okay, just a few more sections to go for Chapter 7. We have 7.5, Factoring a General Strategy, which kind of gives you an overview of everything that we've done so far in Chapter 7. Again, we're not going to do this sum or difference of 2 cubes, so we're going to skip that. So I've weeded out those problems. So first thing to look for is step 1, factor out the greatest common factor if possible. That's not always possible, but if it is, you want to do that first. It'll streamline things. I'll show you how to adjust it if you missed it though. Step 2, determine the number of terms in the polynomial. If you have 2 terms, you might look for the difference of 2 squares and then keep factoring. Again, we're going to skip these two. Difference of 2 fourth powers, you might look for that. If you have 3 terms, you want to see, is it a perfect square trinomial? Do the test for that. Or just factor by grouping or trial and error. If you have 3 terms, it's not always going to be factorable. So don't try to force something. Do the check. Make sure it actually comes back to what you have, not kind of just thinking it might be that way, because you have to factor. It just might be only a GCF, kind of like back at the first section of this 7.1. Then always check. FOIL if it's just 2 binomials, but then multiply by the GCF as well, or anything else that's involved. If you have the 2 fourth powers, you have a lot more to check as well. So let's look at example 7.30, and I'm going to leave that there so you can see it. Factor 18x squared plus 3x minus 3. So on a lot of these, or most of these, I would suggest you pause the video and try it and then see if you're correct. But I'll just go through them all kind of quickly. So in general, I would say this whole thing could be done in that manner as a classwork and then just check and see how you did. But if you're not comfortable yet, just follow along with me. So we're going to look at all 3 terms here and see if there's anything common, which there is. There's a 3, so we're going to factor that out. So I get 3 times quantity 6x squared plus x minus 1. So now we're going to look and see if we can find any further factoring. So if we bring this down to 3, we would have 6 could be split up like this, 3x in one of the set of the parentheses and 2x in the other one. I'm doing factors that are closer together because my middle term is pretty small as well as my end term. So I think I should have them tightly placed. So 1, I only have a couple of choices. I have a -1 and a +1, or vice versa. So let's just do the check. I'm just going to place those there and check that middle term. So I'd have a -2x and a +3x. And looks like I got it right off the bat. Now, if I had those set up backwards, I would just switch the signs. So this is my answer right here. 3 times quantity 3x minus 1 in parentheses, quantity 2x plus 1 in parentheses. So now we have part B. Looks like we have a difference of 2 squares here. 81z squared minus 49y squared. Is there anything common to either of those that I can pull out ahead of time? And there is not. So I'm going to take the square root of the first, which will be 9z, plus square root of the second, which is 7y, times square root of the first, 9z, minus square root of the second, which is 7y. And again, mark your answer clearly, but also check. So I have a 63yz in the middle and a negative 63yz. That give me the 0. And then just check your ends. 9z times 9z is 81z squared. And negative 7y times positive 7y would give me my minus 49y squared. Okay, now we're looking at part C, 100k squared plus 240k plus 144. This is page 103 of your workbook. So we can see here that we have 100k squared, that's a perfect square, and 144 is a perfect square. So if we take the square root of each of those, and we have, so we would have a 10 and times 12 would be 120, and then if I double that, I get the 240k in the middle. So it's a perfect square trinomial. So I know I can use that tactic, but I can also look for a common factor to pull out first. So if I pull that out first, it's going to be a lot easier to work with. So I'll show you that method first, and then I'll show you, if I didn't quite catch that, what I would do. So I would do 4 is what divides into all of those without a remainder. So I would have 4 times quantity 25k squared plus 60k plus 36. Then I still have a perfect square trinomial that I can factor. So I would have 5k plus 6 times 5k plus 6. Just to double check, I would have 15k plus 15, not 15, 30k plus 30k. And that would give me the 60k I need. And I would write that a little more condensed as 4 times 5k plus 6 all squared. So that would be my answer. However, what if I didn't catch all that? So an alternative method is that you could see from here that we have square root of the first would be 10k plus square root of the last term there would be 12 times 10k plus 12. However, I have a 2 that's common, so I could pull out a 2 here. 2 times 10k, 2 times 5k will give me that 10k back there, plus 6. Same thing here, I could pull out a 2. So I would have another 2 kind of sandwiched in the middle there. I'll fix that later. And then I have the same thing, 5k plus 6. So this, if I multiply those two together out here, that would be 4 times 5k plus 6, written as a squared term. Now notice this isn't like factor by grouping where I have pluses in the middle of those parentheses, you know, in between the parenthesis marks, in between the binomials. They're just inside here. So this gives me the same exact answer, but I would say more often than not, if you don't catch the GCF ahead like I did here on the top one, people usually just miss it entirely and get marked wrong. So that's why the electronic homework will really give you a good gauge of that, knowing if you're doing that right. Part D is a difference of 2 cubes, and so we are skipping that one. Okay, for Math 97, we don't do that. You might hit it later in Math 99 or 141 along the way. So part E, we have 4 terms. So we're going to look to see if we can do factor by grouping on this one. So I'm going to separate them out like that. Now see, I have the minus in between the 2 binomials, not just, you know, in the middle. Designate them. So I am going to see what's common. Actually, before I do that, if you notice, there is something common to all of them. So again, check for your GCF first. And I think that'll be a lot easier to work with after that. So if I can pull out the 3 and just put it in brackets so you don't get it confused and mixed in where you don't want it to be. I can pull out a 3 out of all of these. So then that leaves me with 2x squared minus 3, or not 2x squared, 2x cubed minus 3x squared minus 2x plus 3. Now I'm going to use factor by grouping on this part, okay? So I'm just going to carry this 3 down, put my bracket there for now. I can clean it up later. And I have an x that I can pull out here. Let me use a different color. X times 2x squared minus 3. Actually, I can pull out an x squared. And then I have left over, I'm going to pull out a -1 here. It's the only thing I can pull out of that. So remember, this is kind of like a plus -2x. So I'm going to pull out the -1. And I would have left inside there 2x minus 3, because I need to have -1 times -3 would give me the positive 3 back. Now this is my GCF, the 2x minus 3. So I have 3 times 2x minus 3. It's my GCF binomial. Then times what's left is my x squared minus 1. But if you notice, that's a difference of 2 squares. So I can keep going. And so I'm going to go to the next line, 3 times 2x minus 3, and then square root of the first plus square root of the second times square root of the first minus square root of the second. So that is my whole answer. And then do the check just to make sure. Last one here in this section is fn to the 4th minus 625. So I have actually the difference of 2/4 first n squared plus square root of the second is 25 times square root of the first is n squared minus the 25. And now this one I just have to leave. So that one was just ends up you have a sum of the 2 squares by taking the square root. So I did the square root of each of those. But now this one, we're actually going to boil this down further because that's a difference of 2 squares. So we do end up getting really long stretched out. So we get n squared plus 25. And then we have n plus 5 times n minus 5. So do make sure you continue on and keep factoring as much as you can. So you have a difference of 2/4 powers is what I should have said at the beginning. And to the 4th minus 625. Again, get familiar with your perfect squares and perfect fourths and even the perfect cubes. Like, so you notice, like, well, we didn't do the difference of 2 cubes. So if one of those crops up, you can let me know. Or if you're not sure, just ask me if one inadvertently shows up in your homework or something like that. So that is it for this section. Have an awesome day.